Hello everyone, Mr. Minnick's my name, math is my game, and today what we're going to be looking at is our first lesson, and this is on absolute value equations. Okay, we're not officially going to cover this, but unofficially we are, so I would strongly urge you to take notes, to look over this. Maybe later on there might be some exercises over this. They might show up on an upcoming unit test, but I don't think I'm going to assign a traditional homework assignment. So I would urge you to copy these examples down, work them out on your own, check back and see, if you can come up with the exact same things that we got for your answers. So absolute value equations. Before we do that, we probably ought to define, first of all, what absolute value of a quantity And I'm going to put an asterisk there, of a quantity, because everybody knows, and when I say everybody, I mean everybody knows that the absolute value of -3 is 3. And everybody knows that the absolute value of 4 is 4. And everybody knows that the absolute value of -88 is 88. Because, and please, don't think I'm ever dissing your 6th grade teacher, but I'll talk about your 6th grade teacher a lot throughout the year. I'm not dissing them, but they always say, oh, well, this is the easy part of math. Absolute value is easy because everything's positive. And you just took that. You're like, oh, it's easy. It's positive. It's always positive. But did you ever stop and ask or think to yourself, why is it always positive? So to answer that question, you probably ought to write down what it means when we say the absolute value of a quantity. It's a really good idea to write down this definition. The absolute value of a quantity is the quantity's distance, the quantity's, apostrophe S, distance from zero on the one and only number line. Okay? That definition of the absolute value of a quantity is why we have to solve absolute value equations the way we have to solve absolute value equations. So it's the quantity's distance from zero on the number line. That's what the absolute value of a quantity is. Now, if you've forgotten what a number line looks like, I'll refresh your memory. Number line, I need a line. Here we go. It doesn't have to be dotted. Maybe that line could be solid. Let's go ahead and see if I can get that going. Here we go. Okay. So the number line, what's on the number line? Well, we know zero's on it. We know one's on it. We know -1's on it. So here's what happens. When we say the absolute value of -1 equals 1, what represents that is this illustration. How far is this from there? How far away is that dot from 0? And so if you were to grab your magic marker and run over there, you'd say it's 1 unit. And that's why the answer is 1. Now, there's a key word that I'm going to try to highlight. Maybe I'll get my highlighter. There we go. Distance. Some of you run cross country or track, and maybe you like distance, maybe you hate distance. When I ran cross country and track, both, I was a distance runner. And when I ran, I would train anywhere from 50 meters to 30 miles. Sometimes I would run 400 meters. Sometimes I would run 800 meters. Sometimes I would run 5 miles. Sometimes I would run 8 kilometers, which happens to equal 5 miles, in case you didn't know that. The point is, if I'm talking about the distance that the top of my head is from the top of my head to the ground level, when I'm wearing shoes, it's probably 6 foot 3 inches. Without shoes, it's 6 foot 1 1/8 of an inch. Not that anybody's counting the eighth or the whatever. But anyway, the point is distances. Whenever we mention distances, distances are mentioned as a quantity having a positive value. Distances are always positive. Sometimes they're zero, but they're always greater than or equal to zero. And that's a real important component of absolute value that you need to understand. It's something that's very important that you understand. So distances are always greater than or equal to zero. Okay. Distances are always greater than or equal to zero. Real important that you get that. All right. So let's try an example. Example number 1. Solve the absolute value of x equals 2. Now, I know what somebody's thinking. They're thinking, oh, this is easy. It's 2. Well, sure, it's 2. But what they don't stop to think of is, what this is really saying is, I've got an x somewhere. And I want to know how far x is from 0 on the number line. Well, no. What they're saying, what this is saying. No, let me back that thing up. I misspoke. What this expression says, literally translated, is sum x is 2 units from 0 on the number line. That's what that's saying. That's saying that some value of x is 2 units away from 0 on the number line. So 2 units away, well, let's see, there's 1, there's 2. Okay, so there's 2. So there's an x over there. It says some x. We don't know. Maybe there's more than one x. Could an x be over here as well? Well, that's 2 units away also, isn't it? So, visually speaking, I wish this box was set up the way I like them. Maybe I'll go ahead and do that right now. If this will let me. Solid fill. We'll make this an orange. Whoa! Undo that. Okay, so I want this highlighting box to be solid filled with orange, and I want it to be translucent, and I want its line to be red, and I'll save the tool properties. There we go. Cool. Hopefully that stays. So what I've got here is something that says x is equal, something that says, drawing all kind of random squares over everything here. There they go again. X is equal to -2. And this over here, well, let's try that again one more time. This over here says x equals +2 too. So the solution, if you don't know what a solution of an equation is, you might want to write this down. Solutions of equations are values of the variable. Are values of the variable that satisfy the equation. Now, in this context, when we say satisfy, we don't mean Snickers candy bars. Snickers really satisfies. We don't mean that kind of satisfy. In the context of math here, we're talking about making true. So solutions of equations are values of the variable that make true, that make the equation true. So in this context, satisfy means make true. Okay? Make true. Whoop, not make, well, anyway, you get the idea. Solutions are values that make the equation true. So let's see. Let's ask ourselves a couple of questions. Self, is the absolute value of negative 2? 2? Sure it is. Self, is the absolute value of 2? 2? Sure it is. So the point here is that both of these are our answers. Our solution set is comprised of negative 2 and positive 2. And we'll talk more this week about set notation, but in set notation we'd say the solution set contains negative 2 and positive 2. That's my solution set. Okay? So there's more than one answer. There's more than one answer. Now, if I wanted to solve that again, or as they say in Spanish, another time, otra vez, again. If I wanted to solve that again, what I could do is I could let f1 of x equal the absolute value of x. And I could let f2 of x equal 2. Now, I don't know if you understand anything at all about functions, but you can actually use functions to solve equations, and it's awesome. It'll never let you down so long as you understand the functions. Now, we haven't learned about graphing absolute value functions yet in this class. Maybe you recall from last year that if you were to make a table of values and you were to graph y equals the absolute value of x, and you came up with a table of values and you chose x's and you figured out what the y's were, which are the absolute value of x. The absolute value of negative 1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. So that function is going to go through this point, it's going to go through this point, it's going to go through this point. And you could pick some other points, and quickly you'd realize that that function is going to look like this. Let me see if I can make this green. There we go. Bam, 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 bam. There it is. There it is. So that's what f1 of x looks like. f1 of x equals the absolute value of x. It looks like that green thing on the graph. Hopefully you see what I'm going for here. If I make the left side of the equation one function, the right side of the equation another function, f2 of x equals 2. That's just like saying y equals 2. Y equals 2 when? All the time. Y always equals 2. So that's going to look like this. There we go. That's going to look like this. Going to look like this. So what I've got going on there is I've graphed each individual function, and I can solve equations with two functions. To do that, what I want to know is, where do those two functions meet? Where do those two functions intersect? What points do those two functions intersect at? And they intersect right there and right there. Now, the one happens to be the point negative 2, comma 2, and the other happens to be the point 2, comma 2. What you need to know, what you're responsible to be aware of, is the fact that anytime you solve an equation by using functions, the x-coordinate where those things meet, those are your answers. And we saw earlier that the answers were 2 and negative 2. And they are. So some of you might know a thing or two about the TI Inspire Graphing Calculator. And if you do, that's terrific. I'm glad you do. But what I got to forewarn you about, what I got to give you a caveat about, is don't rely too heavily on this calculator, because it's going to let you down. And you're thinking, Mr. Minnick, this equation was so easy. I could have answered it with one hand tied behind my back. Yeah, you're right. It's easy. Piece of cake. I get it. But I want to show you that the calculator is going to lie to you. While we're waiting for that to load, I'm going to go ahead and put up example 2. Example 2, let's go ahead and try to solve this. Negative 3 times the absolute value of x equals Now let me make this plus 4. Let me make this plus 4 equals um, negative 2, let's say. All right. So if you don't know, what you need to know is the first step in solving an absolute value equation is to isolate the absolute value stuff. Because remember, an absolute value of a quantity is its distance from 0 on the number line. Real quick point here, might want to make note of this. If that quantity is ever set equal or being compared to a negative quantity, then that expression, that equation probably doesn't have any solutions. So I need to find out what's going on here. The absolute value of x, if I go ahead and subtract the 4 from both sides, which I should do first, because when you solve equations, it's SADMEP. I'm adding and subtracting the 4, so SADMEP. So we're going to have negative 3 times the absolute value of x. That's going to equal, what's that going to be, negative 6, right? Okay. And then what? Then can I divide or multiply? Or multiply or divide? Yes, I can. I'm going to go ahead and divide by negative 3. I'm going to divide by negative 3. Now somebody's saying, well, why don't you distribute? That's a good question. Why don't you distribute? Well, if you distribute, it's going to be counterintuitive and it's not going to get the absolute value stuff isolated. So don't distribute. So anyway, what we end up with then is the absolute value of x is equal to 2. Dude, that's just like we saw a minute ago, I know. So the solution set would be the same, negative 2 and positive 2. So let me go ahead and bring my TI Inspire in, and I want to show you how that calculator, as good as it is going to lie to you. Okay? So that calculator, as good as it is going to lie to you. So I want to numerically solve NSOLVE. That's something you probably want to put in your notebook. NSOLVE, left parenthesis, negative 3 times absolute value, if you don't know where it's at. There's a math template button. It's found on that. Math template button's next to the 9 key. Okay, so we're going to numerically solve negative 3 times the absolute value of x. Now what else do we have? Plus 4 equals negative 2. Plus 4 equals negative 2. So plus 4. Whoop, got to put that in over here. Plus 4. Oh, man. When it rains, it pours. And solve. There's a lot of latency between my calculator and my smartboard right now. So bear with me. Bear with me. NSOLVE, NSOLVE. Okay. Negative 3, absolute value of x. Come on. Let's go. Let's go. Plus 4 equals negative 2. Now, when you use this NSOLVE, you have to have the equation in parentheses. You have to put a comma x after the equation. And I know that little plus thing at the end is going to mess this up, so I'm going to try to get over and delete that. And I do apologize for the delay here. So this should give me the answers. And it says 2. Problem. We know that there are 2 answers. Okay. Don't always rely on the calculator. It's going to let you down. Don't always think that the answer is going to be plus or minus the same thing. What if we had the absolute value of x plus 3 equals 10? I know what somebody's thinking. They're thinking, okay, x plus 3 is 10, so x equals 7. So the answer is going to be 7 and negative 7, because it's always plus or minus the same thing. Well, is it? Is it? What that expression is saying is that x plus 3, here's 0, here's 10. That's saying that x plus 3 is 10 units away from 0. That's saying x plus 3 is 10 units away from 0. So if we look at this, x plus 3 is 10. X is 7. Bam. That's good. That's good. But over here, this says x plus 3 is also, this says x plus 3 is also negative 10. So x would be negative 13. So this negative 7, it's negative 13 also. Don't always assume that it's going to be plus or minus the same thing. Let's try one more. Example 4. Solve the absolute value of 2 plus x minus 3 equals equals negative 9. Okay. So what I'm going to have here is the absolute value of 2 plus x is equal to negative 6. So if I wanted to solve this by graphing, what I would have for my graph, if I graph this, that's going to be that V-shaped thing that I saw earlier, but it's going to be translated 2 units. You might think 2 units to the right, but it's actually going to be translated 2 units to the left. So that's going to look something like this. It's going to look like that. Then if I graph this negative 6 thing, that's going to be a horizontal line. It's going to be a horizontal line down 6 units. And so the answer is where those things meet. The point here is the answer is where those things meet. Our solution set would be empty. There's no solution. Because those things aren't going to meet. Okay? It's been real, it's been fun. Maybe I'll assign you some homework on this. Anyway, I hope you got something out of this lesson. It's been real, it's been fun. I already said that. Let me give a shout out to the future Mr. Minnick for being such a great guy. And a shout out to my class. Thank you for your courage and your fortitude to enroll in Algebra II What? So I will see you on the live. Maybe we'll try one of these live in class. Thank you. Have a great day. Good.